Okay, we're going to look at this question here from the 2015 paper for the Level 2 Certificate of Additional Maths, WJEC, where we need to find dy by dx of y equals x squared minus 3x from first principles. Okay, so I'm just going to show you the process here. I'm not going to explain each actual step that comes through the teaching. I'm just going to show you exactly how to find dy by dx from first principles from this equation. So we start off by writing the equation at the top. And then on the second line, instead of y, we write y plus delta y. And instead of x, we swap x for x plus delta x wherever we encounter x in the first line. So all I've done, I've substituted y for y plus delta y and x for x plus delta x. Now we need to expand this bracket. We get x squared plus 2x delta x plus delta x all squared, and then we expand that as well. We get minus 3x minus 3 delta x. So remember, we've got a minus outside the bracket, changes both of those positive terms into negative terms. Okay, now the next step is we replace y on the left hand side with what it equals in the first line. The y equals x squared minus 3x. So instead of y there, I'm going to write x squared minus 3x plus delta y equals x squared plus 2x delta x plus delta x all squared minus 3x minus 3 delta x. Well, look at all that lovely algebra. Right, now the reason for doing this is that we can cancel out some terms, because what I'm trying to end up with is something looking like dy by dx, and that's going to come from the delta y and the delta x later on. So by replacing y with what it's equal to, which is x squared minus 3x on the left hand side, I can now cancel out my x squared on there with that side and my minus 3x with my minus 3x over there. And basically what happens, you are always left with delta y on the left hand side and any term that has delta x as part of it on the right hand side. So this had delta x in the term, so 2x delta x. Obviously delta x all squared will still be there, and the last term minus 3 delta x. Okay, so we're almost getting there. Now we want to get something looking like dy by dx. Well, that's what's going to come from this delta y by delta x. What I'm going to do now is divide by delta x. So everything I'm going to divide by delta x. So I get delta y divided by delta x. Now that represents the gradient. That represents dy by dx. The small change in y over the change in x. And this term I'm going to divide by delta x. Every term has to be divided by delta x, otherwise you will change the equation. And hopefully you can see what's going to happen next. I'm going to be able to cancel out some delta x's on this side. That cancels out because basically that's equal to 1. This cancels out with one of those on the top, so delta x squared divided by delta x leaves with delta x, and delta x divided by delta x is 1 there, leaving me behind minus 3. So now I've got delta y divided by delta x equals 2x plus delta x minus 3. Now, we're almost there. Now what we say is that delta x limits to 0 or tends to 0. So basically this term here becomes 0, leaving behind delta y over delta x, which is my dy by dx, which is 2x minus 3. Now what you should check is what would you have done to find dy by dx just using the method. Well, x squared becomes 2x, well that looks right, and minus 3x becomes minus 3, so that's correct. So that's how you find dy by dx from first principles of y equals x squared minus 3x. So I've got that popping up all the time. Thank you very much.